Okay, I see. It looks like a lot of you, most of you, hopefully everyone is here. Uh, Good. Yeah, well, good morning to each of you. I want to mention a few things, a couple changes in our syllabus as we move towards the end of the semester. Nothing major, but just to draw your attention to, I am, and I'll share this with you. So we should be looking at the course Moodle. The next debate was scheduled for the 21st. Instead, I want us to do it on the 23rd. I haven't had a chance to talk about organic foods, and I want to say a little bit before we hear it from you. So Lauren and Courtney and Katerina and Sarah will hear from you next Thursday, the 23rd, not the 21st as originally scheduled. So that should be fine. And as of right now, the final debate will still be on the 28th, which I think is the last day of this. No, it's the 28th for now. If we find we need to move it to the 30th, we'll do that. But for as of right now, plan for that for the 28th. Okay, so that's that. For today, we are going to be talking about finishing up our talk about GMOs. What that all involves. We'd started last week. I know it's been a week since we've met. It might be fading from memory. Oh, before we go on, let me, I sent a note on this, but I just want to be really clear. Everything is up to date in this class in terms of grading, at least as of a couple days ago. So if you have things that are missing, if a few of you have some missing assignments, I sent you a note on that. I have filled them in as zeros, which is where they would stay, and that shows you what your grade would be if you don't turn them in. However, I am flexible in that if you turn it in literally at all, it's going to be well worth your while. If a zero remains there, it will pull your grade down. If you get a 70% because I've penalized you for turning it in a month late, that still is way, way better in terms of the calculations than a zero. So look at your grade. I also mentioned the extra credit for the sugar-free challenge for attendance. That has not been added yet. It will be. So if you did the sugar-free challenge, you will get the extra percent. If you have no more than 2 absences, you will get 2% added to your grade. So you can do that even though it's not officially on the grade book yet. It will be. Yeah, so that's where we are. Send me a text or a chat if you have a specific or an email if you have a specific question about your grade, but they should be up to date and accurate. Okay, the next thing I want us to do then is we'll look at what I have to continue to share with you. So I'm looking at food safety and GMOs. And we had finished up on last Thursday. We were talking about why scientists basically are messing with the genetics of our plants. So we talked about BT, corn, for example. That was the example I used, and it's one of the more common ones, the idea that you insert a gene into the corn and the corn produces its own insecticide. And there may be some advantages because you're not dosing your crops with all these insecticides. I mentioned nutrition, the idea of putting a gene for beta carotene into the rice, and so the part of the rice that is white, if you have white rice, becomes golden, and that provides beta carotene, which then is converted to vitamin A. And in some parts of the world, vitamin A deficiency is a significant problem. Okay, so The next thing I want to talk about a couple more of the common reasons, the reasons why food might be genetically modified. And that's just for production. And a good example of that is for milk. And so I've got a diagram here. Some of you, depending on your biology background, this will be simplistic and very much a review. The idea is, okay, there's the cow, and the cow is producing somatotropin, which is a milk producing hormone. What scientists do then is to take the DNA sequence from the cow that is coding for that hormone, in this case, inserting it into a plasmid, which is a little structure, DNA structure in bacteria. That's plasmid then with the cow gene, the cow hormone producing gene, is reintroduced into a bacterium. And now the bacterium, for reasons that it knows not, but it basically becomes a hormone producing factory. And so it is synthesizing the hormone, the milk producing hormone for the cow that the cow's body responds to. It's genetically identical. And that then you can produce it in almost unlimited quantities at a relatively, and I say relatively cheap price. Okay. And then that can be injected into the cow, and the cow then milk production is ramped up. And I'm going to mention that a little bit more. The same thing has been done for some human hormones, human growth hormones, human insulin. In the days before genetic technology, if you wanted human growth hormone, you would have to isolate it from the hypothalamus, the pituitary, wherever the particular hormone. You'd have to literally isolate it from cadavers, human cadavers. You couldn't use human growth hormone, or you couldn't use pig growth hormone or cow growth hormone. And so nowadays we have relatively cheap and relatively abundant access to human growth hormone in a way that we simply wouldn't have prior to genetic technology. But in this case, the reason that the biotechnology, that the genetically modified, the genetic modification is taking place is to produce milk. So here's how this works. Just a sec here. Okay, so there's a product, this is the commercial product, this is the website for Posilac. Lac referring obviously to milk, and it's an injectable bovine milk producing hormone. And so here's the rationale. A healthy cow supplemented with Posilac produces 10 pounds more of milk per day. And I would say that's 10 pounds more than cows that don't have Posilac. Dairy producers supplement cows with Posilac to help produce a little more milk while using fewer resources. So they're tying it into, oh, this is more efficient, maybe more environmentally efficient. And a little more milk means a more successful dairy business, more abundant food supply for an ever-growing population. You'll hear that tied in a lot. Oh, we need the food. And producing quality, nutritious dairy products. And here's how it goes. So I don't know if you've ever actually thought about the dairy process. So a cow becomes pregnant. In this day and age, it's done with artificial insemination. The cow bears a calf, and the calf is, if it's female, it's saved for future dairy production. If it's male, it becomes often a veal calf, and it's killed relatively young, and that's the veal, which some people like. And oh, you've got this cow that's body's all primed to produce milk for the next several months to feed this calf, but there's no calf. Okay, so you can see then that lactation milk production in terms of pounds per day, it reaches a max at about 8 weeks or so. And then the natural process of the cow's body would be for the lactation to slow down. And after 40 weeks, it's down, quite a bit. Okay. But if the cow is injected with Posilac, this GMO hormone, you can see that that slows the milk reduction, slows the decline in milk production over those weeks. And so the argument is, well, the cow produces more milk. If you're a farmer, you get more money. Now, if you've been following the dairy industry and the fact that milk prices are very low, and a lot of farms, particularly in Wisconsin, but other states in the Northeast, New England states particularly, the question is, do we actually need more milk? That's a legitimate question. So just to be really clear, the cow is not being genetically modified, but it is receiving a hormone produced by genetic engineering. And they've got a handy calculator for the farmers so that they can figure out how much they're going to save. Okay, so that's Posilac, and that's an example then of using GMO technology simply to produce more food, in this case, milk. Okay, and the next one we are looking at is, and this is the big one. So pest resistance, yeah, it's there and it's important. Nutrition, maybe, although golden rice hasn't been widely proved even for production. Milk production, okay, cows produce a bit more milk. The vast majority in terms of acres, in terms of dollars, where genetically modified organisms are used is in herbicide-resistant plants. Okay, and I'll talk to you very briefly, and then we'll look at an example of it. The basic process is a gene was found in the soil, in a weed, which confers resistance to an herbicide. So that gene then is inserted into a plant. Corn, soybeans are the big ones. And then you can spray the herbicide on the field. The GMO herbicide-resistant plants will not die, but the weeds will. So sounds like a pretty useful technology, doesn't it? Let's look at an example of that and how that works. So we are going to our farmer guys yet again and hear their perspective. So this is the farmer's perspective on herbicide-tolerant crops. Here goes.
Basics is brought to you by the LibertyLink Trait and Ignite herbicide from Bayer. The most reliable weed management solution, LibertyLink and Ignite are the link to efficient row crop production and sustainable weed management.
When Roundup Ready soybeans came out about 15 years ago, that was the first herbicide-tolerant trait for crops. And so we wanted to talk a little bit today about why these herbicide-tolerant traits come out and what's the next thing, what's going to come here in another 2 or 3 years.
You know what, Brad, we're standing in a field that was Roundup Ready soybeans this year, and let me tell you, when you're using Roundup out in fields, you're using way less chemicals than we've ever used before. In the past, when we had conventional soybeans or non-herbicide tolerant soybeans, we had to use a lot more pesticides in that field every year. So that's been one of the great things since Roundup Ready crops have come out. The number of herbicides that are being used, the number of pesticide products has gone way, way, way down. Now that's all because Roundup was controlling pretty much every weed that we had in the field. Now there are a few weeds that are escaping Roundup, and just like anything in nature, once you start doing things one way, then nature's going to find a way around it. And there are some weeds that are getting tougher to control.
Yeah, and the whole thing is if a farmer has weed problems, it dramatically hurts yield. So what we're saying is the introduction of Roundup Ready soybeans basically meant less total pesticides were used in the United States and more total food production was out there. We were able to raise more soybeans, and while soybeans traditionally aren't directly eaten by human beings.
Oh, there's a lot of soy foods, Brian.
Yep, but the majority of the soybean crop goes into livestock feed or oil or other uses. But the point is there was more overall produced, and we were able as farmers to use less pesticides. So that was a good thing. So let's talk a little about what's coming here down the road. What's next?
Well, there are a lot of new traits out there. Now, you may look at Roundup Ready crops where you can spray Roundup, or Liberty Link crops where you can spray Ignite. They've been out for a long time. But there are a couple new ones coming that look to be fairly exciting. There's dicamba tolerant soybeans, and there's 2,4-D tolerant corn and soybeans.
So you've probably heard of 2,4-D before, but you haven't heard of dicamba before. Dicamba would be Banville, Clarity, those types of products.
Oh, it's more than that, Brian. It's probably in your garage. If you spray your own yard, you may have some dicamba right out in your garage. Like Trimec, for example, some formulations of Trimec contain some dicamba.
Well,
it's
one of the components of it.
Yeah, it's excellent on controlling weeds in your lawn, and it does the same thing out in fields. It controls tough broadleaf weeds, and these seem to be the ones that Roundup is having more trouble with.
But here's the whole thing with both the dicamba and the 2,4-D today, they'll kill soybeans. I mean, even a whiff a lot of times will kill a soybean plant. So that's not a good thing in soybeans, but we know that the weed problems we're having in Roundup Ready soybeans could be easily controlled by dicamba or 2,4-D. So for the last many years, the development of 2,4-D and dicamba tolerant soybeans has been going on. You want to explain that a little bit?
Well, like the dicamba tolerant soybeans, for example, they were first discovered basically a soil bacteria that produces an enzyme that breaks down dicamba was discovered by a researcher at the University of Nebraska in Lincoln. And University of Nebraska is not in the seed business, so they marketed this trait and sold it to Monsanto, who's breeding it into soybeans right now. Hopefully it'll be released in the next few years, pending regulatory approval in our country as well as other countries like China, who imports a lot of our soybeans. Those soybean plants that are dicamba tolerant are breaking that dicamba down in about 6 hours into a compound that's not herbicidally active anymore. So the plant can metabolize that, so to speak, and break down the dicamba, and you can use it safely for weed control in your crops.
And again, the best part is with the dicamba or the 2,4-D, whichever comes out, whichever gets used, we're only talking 2 or 3 years away, and there will be dicamba tolerant soybeans and 2,4-D tolerant soybeans. We'll be able to control most all of those Roundup resistant weeds. They'll be done. So that's a great thing. Again, we'll be able to get higher yields. And right now, there are many farmers around the country who are using 6 different herbicides to try to accomplish the same thing we'll be able to accomplish with just Roundup and 2,4-D or just Roundup and dicamba in just a few years.
Well, those are exciting, Brian, but will they control our weed of the week? We'll show you coming up later in the show.
Okay, so we watched that. Turn your screens on. I want to have a little bit of a discussion, a little mention, a little bit of a review of what we just watched, rather than me just talking away. Good to see you as well. So what did you pick up from those farmers? What are the advantages of herbicide resistant crops? What were some of the ones that they mentioned or that they asserted?
They asserted less pesticide use because they say it's only like one spray instead of like a bunch of sprays.
Okay.
I mean, is what they were saying, but I don't know if it's like less like intense, I guess.
Okay,
They
no.
said less pesticide use.
Yeah, so they asserted, okay, less pesticide use, both in terms of the amount and the numbers of pesticides. In the past, they said, you'd have to spray several different kinds, but now you only need one. That's what one of them that they said. Those were the big ones. And then, of course, you've got the issue then if there's less pesticides being used, the weeds are being controlled, they're going to increase production, which is, again, good for the farmer. They didn't dwell on the topic, but what do you make of this idea that they said, that some weeds escape? I'll put escape in quotation marks. So they've been spraying Roundup for several years. This video was actually like 8 years old. They had been spraying Roundup, and they're finding that certain plants are now escaping. That Roundup used to control them, and it doesn't anymore. What term would we use for that? What's happening?
Well, it's essentially just natural selection. By killing off the plants, the ones who survive and become resistant to it then reproduce, and
Yeah,
thus they evade the herbicide.
yeah, yeah. So they're developing resistance. And it might be, as Ethan suggests, just through you got billions of seeds being formed, and every once in a while, one of them might develop. And keep in mind, remember what these herbicides are doing. They are interacting, they're blocking certain metabolic pathways of the plant so that it stops growing. Okay, and so either resistance, and this has been an issue, maybe it can be transferred from one plant to another. That's a possibility, or it just emerges, it develops, it evolves in some of the weeds. So what is the solution then? Well, we used to have Roundup Ready soybeans and corn, but now maybe the soybeans, maybe some of the weeds in the soybean crop are Roundup resistant. So we need to put another herbicide on. So that's what they're talking about, this dicamba. And so if you have a dicamba resistant soybean and Roundup resistant, so now you have two resistance genes, then you can spray two herbicides on your crop and hopefully kill all the weeds. But you can sort of sense this is nothing but an arms race. Humans develop an herbicide, they find an herbicide resistance gene, they put it into the plant, and then you can dose the crops with it. But then nature says, oh yeah, we're resistant to that too. And so it's this inevitable arms race between humans and their technology and the weeds. And so it works for a time, and it may in fact reduce herbicide usage, or maybe it reduces the use of the most dangerous herbicides. But I would argue, and I think if you look at actually what's happening, it's not a long-term solution, because even if they do have a dicamba-resistant soybean, it's inevitable at some point that the soybeans or the corn, whatever it is, will all that some of the weeds will also develop that resistance. But that's the argument that they're making. A couple more things then to point out. So as you can tell, I'm a little bit skeptical of this as a long-term solution. And you realize the reason it's as big of a problem as it is because of monocropping. They're growing thousands of acres of corn, thousands of acres of soybeans. And here's another question to ask you. They hinted at it for soybeans. Where is all this corn and soybeans? Where are they all going? Who's consuming them? They mentioned soy, and most of the soy grown in this country is not for me to eat tofu or some of you to drink soy milk. Most of it is going to animal feed. How about the corn? I think I've probably mentioned this, but I'll mention it again. If any of you have driven across the country, driven through Iowa, driven through southern Illinois or southern Minnesota, you can drive for hours, hundreds of miles, and see nothing but corn. The question is, where is that corn going? Who's eating the corn? Tortillas and sweet corn at your family barbecue? Where's the corn going? Cornflakes? Nah. Any of you know?
Wouldn't it be for animal feed too?
A lot of it's for animal feed, yes. So you're getting it via animal feed, chicken feed particularly. They feed corn to cattle as well. There's another big one that hasn't been mentioned, and you're using it, but you may not think of it that way. You're using it even here in Helena. Where are you using that corn from Iowa here in Helena, you personally? Where do you think the ethanol comes from when you fill up your car? Or did someone? Gasoline. Okay, Alyssa, thanks. Yeah, the gasoline. So when you fill up your car and you buy the non-premium gasoline, and it says it might be up to 10% ethanol or something, that is being fermented from corn. Okay. you'll see some places around town saying, you know, we have ethanol-free premium. If you have a high-performance car, some people don't like putting ethanol in because it might not be as good for the engine. But Americans are burning millions, billions of gallons of ethanol in their car engine, and that's coming from corn. We won't go into great detail. There is great skepticism as to whether or not that is a good use of our farmland, quite honestly. The amount of energy that is put into producing the ethanol, some people question whether it's actually equivalent to the amount of energy that we're getting out. And in an earlier era, America was not energy self-sufficient, and so we had to import oil from Mexico, from Canada, from Saudi Arabia. But with fracking, which I know fracking is a whole other issue of concern, America has actually become self-sufficient in oil, and so there's question as to whether or not we should be using millions of acres of farmland to grow corn for our gas tanks. I'm having to smile there, Devin. I see I see your virus background there. Never know what he's going to come up with. Okay, so those are some considerations. I would raise the issue of whether or not herbicide resistance is a long-term strategy, and then secondly, when most of the feed that we're growing is for our gas tank or for animal feed, whether that's still the most efficient use of our land in this country. So keep that in mind. A couple more things I wanted to show you. Okay, just a sec here. Okay, I've got something else to show you because it calls into question. So this is from 2016, pretty recent. You'll notice that one of the assertions made was that they use less herbicides. And this is a research article looking at glyphosate. Glyphosate is the chemical name for what we call commercially Roundup. Glyphosate is Roundup. So let's look at what's happened. Is there evidence that herbicide use has gone down? Let me see here. What did I want to show you? Just a sec. Okay. So this here is looking at glyphosate, which is Roundup, as I mentioned. And it's going back from 1992 to 2014. And it's showing the amount of glyphosate that's being used. And you can see that it's going up and up and up and up and up. You can see that it's been increasing in soybean, which is the green. You can see it's been increasing in corn and in other crops. Okay. You can see that as glyphosate, the price has gone down on the red arrow, and the pounds applied has been going up and up and up. Oh, the emergence and spread of resistant weeds. The cumulative number of glyphosate resistant weeds. So you can see here the numbers are, under 20. This isn't something that shows up in all weeds, but it certainly is showing up in major weeds. And we can see that as the amount of the cumulative number of weeds has gone up, the projected acres with one or more resistant weeds has gone up as well. And so you can see here on the x-axis, the y-axis over here, over 100 million acres have one or more resistant weeds, which is then why they need dicamba resistant crops, for example. Let me go back here. You can see this is one of the earlier crops. This is soybeans. So you can see in the late 1990s into the 2000s, up to 2014, almost 100% of soybean acres, almost 100% has been, that of soy that is grown is now glyphosate, glyphosate resistance, weeds, GMO crops, sorry there. Soybean production, has soybean production increased over time? This is bushels per acre. Okay, so bushels per acre here. And as we go back into the mid-90s, you know, some years were a little bit better, some years were a little bit worse. But it's not clear to me, just looking at this, that the production has increased in terms of yield, bushels per acre. And that was one of the arguments in favor of GMO crops is, oh, you get more bushels per acre, you get better production. This is, so basically what I'm saying is this paper to me challenges some of the assertions of the benefits of these crops. Look at this overall soybean herbicide use. The green bar is the number of herbicides per acre. And you can see the number of herbicides on the scale over here. In the 1990s, it looked like it was about, you know, 2.6 or something like that herbicide. And it is true that into the early 2000s, the number of herbicides, which was one of their assertions, oh, the number of herbicides decreased. And it did increase. Yes, it did decrease. That video was from 2011, and even by 2011, you can see it was starting to increase. It looks like the number of herbicides per acre was at a, what do they call it, the nadir, the lowest point in around 2005. But then since 2005, the number of herbicides per acre has been increasing. So again, it's questionable as to whether or not that is accurate. And the total herbicide use per acre did really didn't decrease. You know, there was a little bit of a decrease maybe from the mid 1990s to the early 2000s, but since the early 2000s, herbicide use in terms of herbicide use per acre has been going up. Okay, so it's questionable that whether or not the GMO crops are reducing the number of herbicides or the number of herbicide or the pounds of herbicides. It's definitely questionable. If you're interested in this topic, this is a great resource dealing with the use of herbicides and in GMO crops. Okay, so that's that topic. Oh, the last one I'm going to show you. And this one hits a little bit closer to home. So I'm going to share this screen. Okay, so this is looking at estimated agricultural use for glyphosate, starting in 2011. And I'm going to just toggle through, and you can see as time passes, where does this start? Actually, it goes a lot earlier. Okay, so here we go. Here's the early 90s. This is, 28 years ago for glyphosate. And as you toggle through, you can see the introduction of glyphosate resistance herbicides. You can see also, look what's happening in Montana. I'm going to go back a little bit. You can see in Montana that we have some usage, certainly not nearly as much, but pay attention. So Montana, some parts of the country are getting darker. Montana stays about the same. In 2011, it starts getting a bit darker. 2014. So you can see there's significant use in Montana, although there's nothing like the use that there is in Iowa and Indiana and Illinois and Indiana and Ohio, these areas. These areas of the country here, This is the so-called corn belt. This is where the corn is being grown. Some of these more southern states, you probably have a little bit more soy, combination of soy and corn. Notice what we have here in California. This is the California Central Valley, which is where much of the country's fruits and vegetables come from. Okay, here we've got Eastern Washington, the grain growing, Colfax, the bean growing areas, the legume growing areas there. What's going on here in Montana? So you can see up in northern Montana, northeastern Montana, and other areas, not quite as heavily, but how is glyphosate being used in Montana? We've talked about corn, we've talked about soy as being the crops that are glyphosate resistant. Are we growing a lot of corn or soy in Montana? Katerina is shaking her head. No, we're not growing a lot of corn or soy. You can barely grow corn in Montana because we don't have a long enough season. And we're definitely not growing much soy. Any ideas as to on what crops or how that glyphosate is being used in Montana? Are any of you from agricultural areas in Montana? Any of you live in a small town or on a farm?
Would it be wheat?
Okay, wheat. Yes. But we haven't actually talked about it yet, but you're right, Ethan, but yet wheat is not genetically modified. So, but yet it is growing, it is being used on wheat. Does that make sense? Before I spoon feed you the answer, why might Montana farmers use glyphosate on wheat, although wheat is not been engineered for glyphosate resistance, or at least glyphosate resistant wheat is not being grown in Montana? It's being used in Montana on wheat and also on crops like lentils as what we call a desiccating agent. What does desiccating mean? It's being used to kill the crop. So again, does this make sense? Montana farmers in August, in September, are going into their field and they're spraying their field with their lentil crop or their wheat crop with Roundup to kill the wheat plant, to kill the lentil plant. And they're doing that so that the plant will dry out for harvest. Our season is short here, and they want to get the crop off before snow comes in maybe September, or we start getting rains in the fall. And so it is being used differently. It is not being used for weed control. It is not being used on a herbicide resistant crop. It is being used to kill the crop so it will dry out so they can harvest it. Okay, does that make sense how I've explained it? That's how it's being used in Montana primarily, not for weed control, but to kill the crop so it dries out, I'm repeating myself, and they can harvest it in because our season is short. That's the story there. To be honest, until I came to Montana, I did not realize that. And a few years ago, there was a student in this class, a health sciences major. I had her in epidemiology and nutrition class. And her family was a lentil farmer. They were lentil farmers, big time lentil farmers in central Montana. And she said, yeah, we spray our crop with Roundup to kill it. And that's how it's used. Okay, so an important insight. And so this is something to consider about, we haven't even talked about health effects. If you're interested, if you're concerned about health impacts of herbicide, I would argue this is almost the worst use of it because they're spraying it on the crop late in the season. And so you're more likely to get traces of the herbicide in the wheat that you're eating, this has been sprayed on. If you're using it in corn, the weed control would be done earlier in the season, and so you're less likely to have it affecting the corn, because Roundup does degrade relatively quickly. And that's one advantage of it. Okay, so I think this is an important insight or an important awareness of an additional use of this herbicide. It's not it's in this case, in Montana's use, it's not being used for genetic on GMO crops, so it's not a GMO issue per se, but it's an herbicide and a food issue, I would argue. Okay, so the next issue then, let's transition. I've talked at length. I spent a lot of time on it because I do think it's an important topic. We get to the issues about GMO safety. The standard that is used by regulating agencies, by the FDA, by the USDA, the government agencies using it, is a standard called substantial equivalence. We know it's not identical because the DNA has been modified, so we can't say, is it identical? Because the answer is no. Different proteins, different enzymes are being produced in the plant, without question. But the term they use is it substantially equivalent? Is there substantial equivalence? Okay, I'm not going to look at this paper. If you're interested in this issue, it's something you might want to follow up on. But substantial equivalence, some questions that would come up is how many substances are measured? Plants are full of various proteins and enzymes. How do they actually determine substantial equivalence? You know, if it's 98% equivalent, 99% equivalent, but even if it's 99%, if you're talking about hundreds or thousands of different proteins and substances, you could still have a number that are significantly different. Is the transgenic DNA and the transcribed RNA, is that safe? The actual consumption of GMO crops. What happens if there is transfer? It's called horizontal transfer. If a resistance gene from a soybean or a corn is transferred to another plant, another weed, for example, what is the impact of that? And then you get to the issue of traceability. We have this world where there are GMO crops and there are non-GMO crops. Much of the rest of the world, other than the Americas, doesn't want GMO crops. How do we trace it? How do we keep track? Okay, this is GMO, this is non-GMO. Because of the spread of corn pollen, it's actually becoming difficult to get non-GMO corn, because much of the corn, even if it's not explicitly genetically modified seed, you have all this corn pollen, corn GMO pollen blowing around, and that will, in a sense, infect or transfer the DNA from the GMO crop to the non-GMO crop. So there's some significant issues there. Many organizations do oppose GMOs. We talked about Greenpeace and GMO Watch. There are others, Center for Food Safety. I'm not going to go on to them, but many environmental organizations are opposed to GMO crops. An issue that has been got a lot of political coverage in the past 10 years is the issue of labeling. In America right now, GMO food products are not required to explicitly say they have GMO in them. We know from earlier that if they say non-GMO or if they say organic, that they are non-GMO. But your average non-organic product doesn't have to specify whether or not it has GMOs in it. Now, several of you are undoubtedly from California, Oregon, Washington, or Colorado. I am interested. I'm going to stop sharing. So I see some of your faces. If you've got a camera, turn it on. Do any of you remember from the past few years any ballot initiatives or any political issues in your state? If you're from Oregon, Washington, California, or Colorado, do you remember anything about GMOs being, a vote being about GMOs? Not particularly. You would have been in elementary school, middle school, most of you. We're going to look at it because since there is no national GMO labeling law, some states individually have put it on the ballot to require that GMOs are labeled in those particular states. Okay, take a look at these. So here we go. In California, here it is, in California, in 2012, Proposition 37, you can see it would have required the labeling of genetically engineered foods. Where is it? Just a sec. Oh, here we go, yeah. So this vote in 2012, Proposition 37 was defeated. So the support was 48%, so 52% voted against it. So it was defeated. The people in California, the voters of California voted against it. Take a look at this. Who was supporting the labeling law and who was opposed to it? And look at the amount of money that was spent supporting it. Okay, so Mercola put in 1.2 million. Kent Whaley, whoever he is, put in $1 million. Dr. Bronner's, a small soap company, put in 600,000. A few others put in a few $100,000. Who was opposed to this initiative? Monsanto, $8.1 million. DuPont, another big agriculture chemical company, put in 5.4 million. Pepsi said, no, we don't want to have to put labels on it. The grocery manufacturers, Kraft, Syngenta, Coke, these are all, look at the amount, look at the dollars. Look at the dollars that were spent opposing the initiative compared to supporting the initiative. And it was defeated by a few percentage points. Next one. Oregon. The state of Oregon also gave their citizens the chance to, the measure would have mandated the labeling of foodstuffs that contained GMO organisms. And it was sponsored by the group called Right to Know. And the measure was defeated. Look at this. Initially, the account was 753,489 voting no, we don't want GMO labels, 752,687. They had a recount and it changed only slightly. But you can see it changed, the total difference out of 1.5 million votes was less than 1,000, 800 and some votes. The good citizens of Oregon said, no, we don't want labeling laws for our GMOs. We're going to look at Colorado and California. I'm going to ask you, why do you think people, when given the chance, say, no, we don't want GMO labeling on our crops, on our food products? In Oregon, very, very close, very close. Okay, next one from the state of Washington. Several of you from Washington. Back in 2013, the state of Washington had a chance to vote on, had it been approved, it would have required certain foods for sale to consumers to be containing GMOs to be labeled as such. What happened in Washington? By 51% to 49%, by, what's that, 38,000 votes or so, the good people of Washington said, no, we don't want GMO labels on our food. Wonder why. We're going to look at one more. Colorado. Colorado. In 2014, they voted it down actually by a comfortable measure. a similar type of vote, but in Colorado's case, it was about 2 to 1, 2/3 to 1/3. They as well said, no, we don't want GMO labels on our foods. So I'm going to ask you, why do you think the good people in Oregon, Washington, California, and Colorado all said, no, we don't want GMO labels on our foods? What do you think? Someone jump in, or else I'll call on a name. Katie, why do you think, Katie Donaldson, why do you think people in those states, when given a chance, said, no, we don't want to know GMO labels on we don't want GMO labels on our foods?
Maybe those companies were worried about the amount of sales they were going to be getting.
Okay, so we saw the data from some results from California. It would have been similar in other states, that the food companies lobbied and advertised against GMO labeling. What do you think some of their arguments would be? Serena, do you have, why do you think some arguments from the food companies against GMO labeling? Not sure? Okay. Devin, any ideas? Oh, sorry, didn't cut you off. Go ahead, Serena.
Oh, that's okay. I was just gonna say they could argue that it limits people's choices, or like it can be hard to label because some things aren't completely organic.
Okay.
Like, it can be hard to identify what is genetically modified and what is not.
Okay. So maybe the crops, some of the ingredients are GMO, some of them aren't. Devin, do you have any insights as to why people would vote against labeling of these crops, of these food products?
Since they do grow GMO foods, they're going to be using them, and if you label them, then people are not going to buy them. And since it's a lot harder to have non-GMO foods as like our main source, it would be difficult to keep a food supply.
So, David, you raised the issue of people aren't going to buy them. That's some people have asserted that, and some people have questioned that. The fact is, right now, unless you are buying organic, if you're buying products that contain corn or soy at Vans or Safeway or Albertsons or something like that, unless they're labeled organic, you're eating GMO foods.
Yeah,
that's just a fact. And the question is, and you raise it in a good way, Devin, as to whether or not sales would decrease if people actually knew there was GMO foods. And so the issue becomes, do you think people care about GMO or not, or whether people are just saying, hey, I want the cheapest foods possible? Take a look. I've got a montage, a series of video ads, of ads that ran in California, both by the people arguing in favor of the ballot initiative that would require labeling, and the groups arguing against it. Pay a close attention, because I want to review with you afterwards what are the arguments being made in favor of labeling and against labeling. Okay, so take a look at this. Okay.
Because food is love, food is life, food is family. We all have the right to know what's in our food. That's why the California Nurses Association, consumer groups, and thousands of others say yes to 37. Pesticide companies like Monsanto and Dow shouldn't be able to hide that they are genetically engineering our food. 61 other countries already have the right to know, shouldn't we? Simple, clear, doesn't cost a dime. Yes on 37, the right to know what's in our food.
Doctors in all parts of the country were asked, what cigarette do you smoke, doctor? See how mild and good tasting a cigarette can be. DDT. Used right, it is absolutely harmless to humans and animals.
The herbicide will open up ground areas.
Big agrochemical corporations have produced genetically engineered corn that includes insecticides. Not on the corn, but in the corn. A new study links genetically engineered corn to tumors and organ damage. And the big agrochemical corporations also say BT toxins are safe for us to eat. We shouldn't be forced to gamble with the health of our families. We have the right to know what's in our food. Vote yes on Proposition 37.
Okay, so those were some of the pro Proposition 37. Let's review and talk through a little bit. What were the main reasons, the main thrusts in favor of this initiative? Talk to me.
They specifically linked it to harmful diseases that occurred. They also stated about 61 other countries already doing this, so why can't we?
Okay.
And they specifically call out I forget the name of the brand, but they said if they're saying it's safe, why are they trying to hide it?
Mm-hmm. Okay. So yeah, you summarize them. Other countries have labeling laws. You notice the emphasis was on our right to know. Okay, shouldn't we know what's in our food? Other countries have that right. Why not Americans? Sort of appealing to American, hey, you know, liberty and freedom and right to know, right to make informed decisions, things like that. One of them did mention, oh, it's not going to cost us anything. That was meant briefly. You notice the most recent one, the last one we saw, it talked about the pesticide being in the corn, not on the corn, and that is true. We talked about BT already. Anything else that you picked up? There was one other sort of line of attack that was mentioned. The one that talked about cigarettes and DDT. What were they getting at there? The issue that in the past, companies, medical organizations even said, cigarettes are safe and DDT is safe. And we've subsequently learned that maybe they're not safe. Well, no maybes about it. So it's trying to challenge the credibility, and maybe we'll find out in 2 years or 5 years or 50 years, what the hell were we doing messing with our food supply? Maybe we'll have an epidemic of disease X, Y, or Z. Okay, so calling into question, can we trust these companies? The next set of ads focus on why people should vote against Prop 37, which, as you recall, was successful. People did vote it down. So here goes.
Farming is very important to our local economy, and Prop 37 is bad for farmers. It would create a bunch of costly red tape and food label requirements that don't exist anywhere else, and then let the trial lawyers sue us just by claiming that the wrong wording was used on the label. 37 is unfair to California family farmers and would increase food costs for consumers just to make the trial lawyers richer. Please stand with us and vote no on 37.
As a doctor and a mother, I believe information on food labels should be factual and reliable. That's why I oppose Prop 37. It's a complex, inconsistent labeling measure that would give consumers misleading information about the food that they eat. And by increasing our grocery bills, it would hurt families who can least afford it. I'm joining other doctors, Nobel Prize-winning scientists, and California organizations to urge no on 37.
As a doctor, it concerns me when families are given misleading health information. That's why I urge you to vote no on Proposition 37. 37 proposes a food labeling requirement the American Medical Association called scientifically unjustified. Administering 37's complex regulations would waste millions of tax dollars that could be better spent on health programs. And 37 would increase grocery bills for California families. Please join me in voting no on 37. Thank you.
Under Prop 37's complex, badly written label regulations, some foods would need special labels to be sold in California, while others would get special exemptions. This illogical, unfair labeling proposition makes no sense, and it would increase costs for California farmers and food companies by over $1 billion per year, and increase grocery bills for a typical family by $400 per year. No wonder nearly every major newspaper in the state urges no on 37. Check the facts for yourself.
Farmers already face a devastating drought, causing higher food prices. Now California farmers are threatened by Prop 37, a complex bureaucratic food labeling proposition that would increase costs to food producers and consumers by billions of dollars.
It's going to put the California farmer at a disadvantage with the other 49 states. The people that are least able to pay are going to be forced to pay more. Please join California farmers in voting no on Prop 37.
Okay, let's talk through and review and dig into a little bit more. What were some of the major reasons that were given by the anti-Prop 37? Let me call on Madeline. Let's talk through. What did you hear?
They said that it would be misleading, and then people would be paying more in the grocery stores.
Okay, so the cost issue, and several of them mentioned this $400. And maybe there's inconsistencies or misleading. What else? Courtney, what else did you pick up?
They had doctors, so that made them more credible.
Okay, so this idea of appealing to experts. I'm a doctor, I'm a mom. And in our society, when it comes to anything related to health, we assume that someone who's gone to medical school knows more about health. And without question, they know more about some things. I would question whether they know more about all aspects of food and health, but so this sort of appeal to experts. So you see these youngish women doctors, and they obviously are concerned about their patients, their family, and they're saying this is a bad idea, and we look at someone in a white coat as an expert. Notice also they appealed to the American Medical Association. They also appealed to newspapers. Okay, the idea of editorials, editorial boards. So okay, so they appealed to experts. What other group did they feature as being opposed to it? Sarah, did you catch that? Sarah Swingley? What other type of?
They highlighted like small business, like farmers.
Farmers.
Yeah,
yes.
This would be an attack on them.
Okay, and notice that they always use the term family farmers, family farms. They didn't say big agricultural companies, but they said the family farm. There's something in our North American heart sort of that still sort of idealizes, romanticizes the small family farm. They're scratching a living, an existence out of the soil. The fact is most of those are gone. Yes, there are still farms that are owned by families, but in most cases, they're large operations. But the farmers are speaking against it. So we heard from farms. And then they talked about, what was the issue about the trial lawyers? We as a society maybe don't have quite the same appreciation or warm feelings for trial lawyers as we do for farmers. How are the trial lawyers going to get involved? Did you pick up on that, Lauren? She's shaking her head. Katerina, did you pick up on the trial lawyers?
Yeah, they were saying that like because of the wording of this bill, that the trial lawyers were going to be able to get like more money because they'd be able to sue more companies. Because of the wording on their labels.
Exactly.
So it's just like a get-rich scheme for the trial lawyers.
Okay, so they're an easy target, and so we've got these family farmers, and they're being sued by the trial lawyers because the labels aren't properly done properly, or they missed some of the regulations. Yeah, those are some of the main ones. So you can see that despite having millions of dollars more to spend, the anti-Prop 37 barely beat those voting in favor, barely. But they did, and so the law wasn't passed. It didn't become, wasn't enacted. Okay, so I always like looking at that because it illustrates how we as a society try to influence people's feelings. Those in favor of it sort of, hey, it's my right to know. Oh, it's going to cost more. Oh, the experts are saying it's safe. These are common strategies that are used to try to influence public opinion. And we'll see that's in the upcoming election. Whatever the issues are, if it would have been Bernie Sanders running against Trump, it would have been, Medicare for all. Oh, it's going to cost too much. You're not going to be able to choose your doctor. Okay, I don't think Joe Biden's going to be proposing Medicare for all, but there definitely are going to be issues. So when you see ads, try to be critical and say, okay, how are they trying to influence me? What is their approach? Is it appealing to experts? Are they trying to scare me? Are they trying to say it's my right? Okay, those are all common approaches. A couple more things here. We got about 9 minutes to go. I'm not going to activate or click on all of these. The state of Vermont took a different approach. The state of Vermont says they looked and they'd seen that in every case that the citizens had voted it down. So what Vermont did was they passed a GMO labeling law in the state legislature. And in the absence of a national policy, a national law, states do have that right. But then that got the US Senate and House to pass a national GMO labeling law, which would then supersede. And so we are in a transition phase where a national GMO labeling law is coming into effect. But the Vermont law did not come into effect because there is a national law. Some companies are changing their attitude. Again, I'm not going to click on this. The grocery manufacturers had been against labeling, GMO labeling. And they spent millions of dollars, the Grocery Manufacturers Association, against it. But some individual companies, big companies like Campbell's, like Nestle, left this trade organization, at least in part because they, as a company, said, well, maybe we will put our own labels on. We won't wait for government legislation. We won't fight government legislation. We'll just put the information there. Okay, and so some companies have done that. Some companies have voluntarily removed GMOs from their crops, from their foods. Here we go. Okay. So Chipotle Mexican Grill. I don't know that we have them in Montana, but I'm sure some of you have eaten there, yes? Okay. What is Chipotle known for? What is their sort of their commercial, their business attitude? Why do you think they've been so successful? How does Chipotle, for example, compare to Taco Bell in terms of the food that they're selling? Any of you eaten at both places? What's the difference? No takers? Okay. Chipotle, they are trying to promote their food as being healthier, more natural, whatever that means, that meat is raised in a more humane manner. So basically, they're trying to position themselves as being higher quality, more ethically, environmentally responsible. We to source the very best ingredients, we prepare them by hand. They're grown in healthy soil. Pork from pigs allowed to freely root and roam outdoors or in deeply bedded barns. There was a time, a year or two ago, where actually a certain pork dish on at Chipotle, they stopped selling it because they couldn't source enough meat that was raised to the standards that they expected. I guarantee you Taco Bell isn't really caring about that. Taco Bell, it's all about cheap and getting it at the cheapest price possible. So Chipotle has been very, very successful in many markets because people want, so that people care about how food is raised, how it's prepared, how it's tasted. We do it for farmers, animals, the environment, talking about space for animals, long-term partnerships, respecting the soil. Okay, they're not mentioning GMOs specifically anymore. Previously they did, but it's all about higher quality, responsibility as much as possible. Okay, so they have done that. They have removed GMOs voluntarily, and other companies have done that as well. Have any of you heard about the butterflies, the monarchs, when it comes to GMO? There was a report back several years ago, and I'll share this with you. Okay, Nature magazine, this is 20 years ago, almost 21. We know monarch butterflies are these migratory butterflies. They go to California and they cluster on trees, and they're famous. And a report came out 21 years ago that pollen from GMO corn harmed the monarchs. Okay, so what they did, and this is looking at this BT issue, which we've talked about. BT corn plants might represent a risk because most hybrids express the BT toxin in the pollen. And what they did was they put some of this pollen from the BT corn on milkweeds. And they found that larva survival after 4 days of feeding on leaves dusted with BT pollen was lower on larva than survival on either leaves dusted with untransformed leaves or leaves with no pollen. The monarch butterfly eats a specific plant called a milkweed. They took BT corn pollen, put it on the milkweed. They put non-BT corn, and they had some milkweed with none. And they looked at the survival of the larva. And you can see that the leaves dusted with BT pollen, dark blue, that the survival of the monarch larva decreased over time. Nature magazine is a world famous scientific journal. This got a lot of coverage. Save the monarchs. Don't risk the monarchs. Don't threaten the monarchs with GMO organisms. Okay, so this raises some significant concerns then. The USDA, the government agency, their response was this. Okay, so here's question and answer about BT corn. Does it present a risk? What was different? What prompted this risk? They say there's no significant risk to monarch butterflies from environmental exposure to BT. Corn might present a risk, that it might present a risk, comes a small experiment. That's a good way of discrediting a scientific experiment. If you say, oh, it's a small experiment, a small sample size, it doesn't have statistical significance or validity. And notice the language they use here. A small experiment indicated that caterpillars suffered when given no choice but to feed on milkweed leaves heavily dusted with BT corn pollen. Do you catch that language? No choice, heavily dusted, a small experiment. These guys don't know what they're talking about. What was different about this research? And so they go about basically discrediting the research that suggested that the butterflies might be at risk from this BT pollen. Okay, there's a lot at stake with these issues, a lot. And so the USDA successfully resisted the concerns. basically. I haven't heard much about this recently, but it was an important episode in this whole issue. Okay, we're coming to the end of our class. There is actually a little bit more that I want to say, and we'll do that on Tuesday, and then we'll talk about organic and what that means. I'm spending a lot of time on this because from my perspective, this whole issue of GMO gets to the heart, to the essence, in a sense, of what is happening to our food supply, bringing in politics, bringing in big business, bringing in science and how we deal with the science. So I find it a fascinating topic, and I want to give you a good dose of it as you move on with your lives and your careers. And you may very well decide that GMO is good, but at least I want you to decide based on a knowledge of how we have got to where we are with our food system. Okay, so next week we're going to talk about, as I mentioned, organic. On next Thursday, we'll hear the debate where we're going to drill down a little bit more on some of these issues of organic food. And then the following week, just looking a bit at seeds, alternative agriculture, basically getting us to think more broadly as where is our food coming from? And I may spend some time next week as well talking about some of the concerns that are being raised about our food system with the virus that we're dealing with. You may have heard there is a pork processing plant in Sioux Falls, Iowa, I think it is, that provides 4 to 5% of all the pork in America is being shut down because workers are infected with the virus. If pork slaughtering, processing plants start closing down, beef processing, chicken processing, it's not just going to affect meat. Who's going to be harvesting the fruits and vegetables? So causes for concern, quite honestly. We're not seeing it yet, but it could have impacts more than we're thinking about right now. So grow your own. Easier said than done, and I know that full well. So I will wish you all a good weekend. Finish up any missing assignments. If you have anything that's missing, there are no, other than finishing up the debates. Let me just a sec here. One more thing. Actually, I'll talk with you on Tuesday. There we go. On Tuesday. I think we're good enough to go, and I don't want to keep you over time. So thanks for being here. Goodbye to all, and I'll see you when you check in next Tuesday. Bye.